So in the options, when you observe, they are asking us to identify the variation of acceleration due to gravity with increasing height and depth. So let us understand what happens. As we know that our Earth is a sphere, solid sphere of uniform density. Then, as we know that the gravitational field intensity, the variation of gravitational field intensity, we have studied in the whole chapter that the gravitational field intensity, that is acceleration due to gravity, is constant on surface, and when it moves away, that is when its height increases from the surface, then acceleration due to gravity value decreases, and when its depth increases, that is when it moves towards the center, then also the acceleration due to gravity value decreases. And further, when it moves towards the center, then we get the gravitational field intensity at the center becomes zero. So this was the rough idea. Let us understand with the formula based representations. We know that when our h is nothing but height measured from the surface of the earth. Okay, h is the height measured from the surface of the earth. When our h and capital R be the radius of the earth. Okay, let the capital R indicates the radius of the earth here. Then when our h is comparable to capital R, that is the height from the surface of the earth is comparable to the radius of the earth, that is if h value is equals to r by 2 or 2r or etc., then in that case the acceleration due to gravity at that certain height will be given by g dash is equals to g by 1 plus h by r whole square. So you can observe here that as the h value, that is height from the surface of the earth, increases, then the overall denominator value will be increasing. As the denominator value is increasing, then this whole value will be decreasing. So you can observe that as h is increasing, the as the height from the surface of the earth is increasing, then g dash value is decreasing. When this was the case when the height was comparable to the radius. If height from the surface of the earth is very much less than r, then also you have the formula, that is g dash is equals to g of 1 minus 2 h by r. H by r. So here also the same case, when the height value increases, then the whole value will be decreasing. So this whole value, as this whole value decreases, we can say that g dash is also decreasing. So what we conclude here, that whenever the height is increasing, our acceleration due to gravity value will be decreasing. So in the same cases, you find the both result, in the both the cases you find the same result. So what you can conclude, that the acceleration due to gravity decreases with increasing altitude, that is nothing but height. So our option A is true. Moving to the option B. Option B says that acceleration due to gravity increases with increasing depth. Let us try to understand that. We know that as depth we know that the variation of g with respect to the depth, we have a certain formula, that is g at depth is given by g of 1 minus d by r. Here d represents the depth measured from the surface of the earth. That is, if this is the surface of the earth, then this d is measured from the surface of the earth. When the d value increases, that is when the depth from the surface of the earth increases, then what happens over here is this value will be increasing. So this overall value will be decreasing. So what you can find here is, that is the acceleration due to gravity will decrease as the depth increases. So our option B says that the acceleration due to gravity will increase with increasing depth. This is not true. So our option B is wrong. Coming to option C, in option C you can see that the acceleration due to gravity increases with increasing latitude. Let us verify that. Yes, we know that the acceleration due to gravity value at any certain latitude can be given by the formula g phi is equals to g minus r omega square cos square phi, where phi represents the angle of latitude. Okay, latitude angle. So we know that latitude are nothing but they are the imaginary lines on the globe, horizontal imaginary lines on the globe. So we know that the latitude angle of the equator is 0. So what happens if if this latitude increases? That is, if the latitude angle increases, then we know that here the latitude angle is equals to 0. That is our equator. So what happens when the latitude angle increases? Our this term cos phi values will be decreasing, because we know that when we put the increasing angle, value, increasing value, that is 5 when increases, then our cos phi values will be decreasing. So what we conclude that this overall term value will be decreasing. So when this overall term value will be decreasing, then indirectly we say that this g phi value will be increasing. So what you find that with the increasing latitudes, that is with the increasing latitudes, the acceleration due to gravity will be increasing. So our option C, let us check our option C. In option C, they say that the acceleration due to gravity increases with increasing latitude is true. Coming to option D, in option D, you can see that the acceleration due to gravity is independent of the mass of the Earth. This is completely wrong because we know that acceleration due to gravity of the Earth is given by G is equals to G capital M by R square, where G represents the gravitational constant and R represents the radius of the Earth and M represents the mass of the Earth. So you can directly see here that G value depends on the mass of the Earth. So our option D is wrong. So overall option A and C are true.